Welcome to Networks Professionals.
Welcome to The Explainer. Today, we're zeroing in on why OSPF is absolutely the gold standard for enterprise networks. If you've ever found yourself wondering how mountains of data somehow navigate these massive, sprawling corporate infrastructures without just getting lost in the void, well, you're in exactly the right place. We're going to break down the mechanics, the underlying math, and the specific design rules that make this routing protocol such a powerhouse. So think about this massive logistical problem for a second. Imagine a city jam-packed with millions of cars, all constantly moving. Suddenly, boom, a major bridge collapses. How in the world do all those cars instantly figure out the next best route without causing total citywide gridlock? That is literally the exact challenge our enterprise networks face every single second. We have to avoid those digital traffic jams and figure out how data actually knows exactly where to go, even when the physical infrastructure shifts or outright breaks. And the answer to that logistical nightmare? It's OSPF, or Open Shortest Path First. Technically speaking, it's a highly scalable, dynamic link state routing protocol. But what does that actually mean in plain English? Well, think of it like a hyper-advanced GPS system purpose-built for your network. It doesn't just know a single path. It's perfectly engineered to constantly calculate the absolute best, most efficient routes. And critically, it adapts on the fly the second a link goes down. Let's step right into Section 1, the engine room, how OSPF works. At a high level, the protocol's operation basically boils down to three distinct, incredibly efficient steps. We've got the link state algorithm, topology awareness, and triggered updates. Truly understanding these three pillars is the absolute key to grasping why OSPF is just so incredibly robust. Let's break them down. First up, the absolute mathematical powerhouse behind Step 1, Dijkstra's algorithm. This specific algorithm is the magic that ensures your traffic always takes the optimal route. It does this by actively, mathematically calculating the absolute shortest and fastest path to every single destination across the entire network. Now, once that math is crunching away, we need topology awareness. This relies on the LSDB, or Link State Database. And honestly, this part is fascinating. Every single router in the OSPF network gets an identical, comprehensive map of the entire network topology. Think about that for a second. Every single router has the exact same blueprint. There's zero second-guessing going on, because every device has 100% full visibility of the entire landscape it's operating in. Finally, we have triggered updates. You know, older protocols used to just broadcast their massive routing tables on a set timer, which is a terrible waste of resources. OSPF is way smarter than that. It saves precious bandwidth by multicasting changes only when a specific network alteration actually happens, like say a fiber cable gets cut or a link drops. Basically, it only talks when it actually has something important to say. Moving right along to Section 2, Design Rules, Key Protocol Characteristics. So first things first, we need to categorize this. OSPF is an IGP, an Interior Gateway Protocol. The crucial word to remember here is interior. It is purpose-built to manage traffic exclusively inside your own organization's boundaries, your administrative domain. It is not designed to route traffic out across the global internet. It's strictly for keeping your own internal house in perfect order. And that brings us to how it scales so brilliantly. OSPF enforces a really strict hierarchy. Instead of forcing routers to process one gigantic, messy map, it breaks large networks down into smaller, highly manageable areas. Everything ultimately connects back to a core backbone known as Area 0. By splitting things up like this, you actually isolate network instability. If something flaps or goes offline over in Area 2, Area 4 doesn't have to process all that noise. It dramatically reduces memory usage and CPU load on your routers. So how does a router actually know if one path is better than another? Well, it relies on a metric quite simply called cost. This cost is mathematically determined by taking a reference bandwidth and dividing it by the interface bandwidth. To put that in simple terms, the faster the physical link, the lower the cost. And OSPF will always, without fail, prefer the path with the lowest total cost. Let's jump into Section 3, Real-World Dominance, Popularity in Enterprise Networks. Look, OSPF continues to absolutely dominate the enterprise space, and it's not just theoretical, it's for a few highly specific practical reasons. There are three key traits we're going to look at that make life infinitely easier and much more reliable for network engineers who are just trying to keep the business online. First up on that list, it is entirely vendor agnostic. Because it was standardized by the IETF, you are never locked into buying hardware from just one brand. That means your Cisco core switches, your Juniper edge routers, and your Fortinet firewalls can all communicate flawlessly. OSPF just speaks a universal language. The second big reason is fast convergence. In the networking world, convergence is just the time it takes for all routers to agree on the new map after something changes. With OSPF, when a link goes down, convergence is almost immediate. Your massive, complex enterprise network recalculates its GPS routes so fast that the end user sitting at their desks probably won't even notice there was a hardware failure in the background. And finally, it is completely ready for the future. With OSPF version 3, the protocol natively processes IPv6. As the world continues running out of those old IPv4 addresses, transitioning to IPv6 is basically mandatory now. OSPF v3 ensures that your internal routing infrastructure is totally future-proofed for the next generation of internet addressing. You set it up once, and it just scales with the times. Which brings us to Section 4, your next steps, where to go from here. We've definitely covered a lot of ground in this explainer. Now that you've got a solid grip on the core mechanics and the massive enterprise value of OSPF, your next step really depends on what you're building. If you're architecting a massive infrastructure for a campus or a global enterprise, you're probably going to want to dive deeper into exactly how to physically and logically plan out those hierarchical areas, branching off from that Area 0 backbone we talked about. Or hey, maybe you're totally past the planning stage. Maybe you're ready to get your hands dirty on the command line right now. If that's the case, your next move is to seek out the practical, specific syntax to actually implement this on your exact hardware, whether that means typing out the commands in Cisco iOS or configuring the GUI on a FortiGate. And finally, maybe you're looking at the bigger picture. Are you curious about how this specific protocol stacks up against the other heavyweights in your networking toolkit? Like, how does it actually compare to a distance vector hybrid, like EIGRP, or even BGP, the protocol that runs the global internet itself? Look, OSPF is an absolute masterpiece of network engineering, but it is just one tool in the belt. So now that you know exactly how the engine works, which part of the network are you going to build next?
Thanks for watching.